converse of midpoint theorem. What is converse of midpoint theorem? So write that theorem. The line drawn through the midpoints of, this is converse. Again, triangle ABC. The line drawn through the midpoint, let's this E. Midpoint of one side of a triangle parallel to another side bisects third side. Given E is the midpoint of BC, a line drawn through E parallel to BC. Okay. Bisects AC. So we have to prove F is the midpoint of AC here. So to get that, let's start. Let's draw a line from C parallel to BA. So draw this one, which is parallel to this BC to meet EF produced at, it will be D. Here these are parallel. Okay, already we have these two sides are parallel. Now opposite sides are parallel. Okay, so construct CD parallel AB. AB or BE. Okay, AB means BA. CD parallel BA, which implies CD parallel B. Also ED parallel BC. Because EF parallel BC, ED is EF extended. Okay, produce EF to D to meet this parallel line at D. Now ED parallel BC. Now opposite sides are ED parallel BC, BE parallel CD, because BCDE implies BCDE is a parallelogram. Okay, BCDE is a parallelogram. We know that in a parallelogram opposite sides are equal. So, which implies BE equal to CD. These two sides are equal. BE equal to CD. Okay, BE equal to CD. BE also equal to AE, because E is the midpoint of AB. BE also equal to AE. Okay, so these two are equal, which implies CD equal to AE. Okay, CD equal to AE. BE equal to CD from parallelogram. BE equal to AE because E is the midpoint. So AE equal to CD. Now consider these two triangles here. These two angles are equal because alternate interior angles are equal. Okay, 1, 2. Angle 1 equal to angle 2 alternate interior angles. Also, AE equal to CD. Just got. Then these two angles are equal. Vertically opposite angles. Now AS congruency, triangles are congruent. Okay, so these two triangles are congruent. Then we can say that AF equal to CF. Then we get, after proving two triangles AF, E and CFD congruent, we get AF equal to CF. So when AF equal to CTCD, then F is the midpoint of AC. So that is converse of midpoint. So no need of writing the proof. Okay, we study that and write both theorem. So let's start. Given a quadrilateral ABCD. ABCD is a quadrilateral, and what are given? PQR and S are the midpoints of AB, BC, CD, AD. Okay, midpoint of AB, P, midpoint of BC, Q, midpoint of CD, R, midpoint of AD, S. Next, AC is a diagonal. Given AC is a diagonal. Okay, AC a diagonal. That's also given. So join AC. SR parallel AC. First to prove SR parallel AC, SR equal to half AC. SR, so join PQRS. To last till we have to prove PQRS is a parallelogram. So join PQRS. PQRS. Now it's a quadrilateral. PQRS is a quadrilateral now. So here we have to prove that last one PQRS is a parallelogram. So start with first one, SR parallel AC. To get SR parallel AC and SR equal to half AC. Okay, SR parallel AC and SR equal to half AC. How to prove that? So consider the triangles. We have to use midpoint theorem. So first consider here after joining AC. Okay, we have two triangles now, ABC and ADC. So consider triangle ABC first. in triangle ABC. Here, two midpoints are given. Midpoints of sides AB and BC. P and Q are the midpoints of sides AB and BC of triangle ABC. Then we can say that by midpoint theorem, PQ is parallel to AC and PQ is half AC. So, see this big figure. Suppose when ABC is like this, A, B, C, and P, this is PQ, P, Q. Then we get P and Q are the midpoints. So, we can say that these are parallel and this is equal to half of AC. So, that is the theorem, midpoint theorem. Now, consider that one. First, in triangle ABC, P and Q are the midpoints of AB and BC. Okay, which implies, now which is a new line segment for PQ. So PQ is parallel to third side is AC, which implies PQ parallel AC and PQ equal to half AC. So this is theorem reasoned by midpoint theorem. Okay, sorry. That will be equation number 1. Equation number 1. Now, second, consider second triangle in triangle ADC. In triangle ADC, which are the midpoints in ADC? R and S are the midpoints. R and S are the midpoints of which sides? CD and AD. CD and AD implies the lines, new line segment form is RS. RS or SR. Okay. SR is required here, so write SR here. SR. Parallel. This AC. Third side AC again. And SR equal to half AC. Okay. Number 2. Reason midpoint theorem. Okay, by midpoint theorem. Now consider 1 and 2. From equation 1, we have PQ parallel AC. PQ equal to half AC. Equation 2, SR parallel AC. SR equal to half AC. So both are parallel to same line AC and half of same line AC. So then we can say that PQ and SR are parallel and equal. Okay, two lines parallel to same line are parallel to each other. So PQ and SR are parallel. And when one line segment is half of the other and some other line segment is half of same, then we can say that the two line segments are equal. So PQ equal to SR. So from 1 and 2, we get PQ parallel SR and PQ equal to SR. So first one, SR parallel AC, SR equal to half AC, that we have proved here. Okay, so start with this one. So for the first one, you start with this one, write the second one. So SR parallel AC, SR equal to half AC. This is the second equation. So we have to start with this equation. So you start with this one. So let this equation be 1 and this equation be 2. Okay. Now we have, this is the first answer. Now connecting the 1 and 2, we will have the second. That will be equation number 3. So in equation number 3, we have same sides, pair of sides, parallel and equal. Then we can say that the figure obtained is a parallelogram. That is the third one. PQ parallel or SR and PQ equal to SR implies this PQRS is a parallelogram. Then which implies PQRS is a parallelogram from 3. Okay, so answer 1 completed. Write that answer. Next 2. ABCD is a rhombus and PQ and RS are the midpoints of sides AB, BC, CD and AD respectively. So that quadrilateral PQRS is a rectangle. Okay, ABCD is it is given that ABCD is a rhombus. So start with a rhombus. We know that in a rhombus, all sides are equal. In a rhombus, all sides are equal. So here ABCD is a rhombus. A, B, C, D. Rhombus means all sides equal and opposite angles equal. Diagonals are perpendicular to each other, perpendicular bisectors. PQRS are the midpoint of AB, BC, CD, DA. Okay. P, Q, R, S. Okay. These are the midpoints of the sides. Now what is to prove? Show that quadrilateral PQRS is a rectangle. PQRS is a rectangle. That is to prove the join PQRS. PQ. Okay. In the previous, from the previous question, we have PQRS is a parallelogram. Now here we have to prove PQRS is a rectangle. Parallelogram, that is the first step. For every quadrilateral, at least parallelogram is there. Okay. So to prove this is a rectangle. So start with the diagonal. Start with one diagonal. Okay. Now, let's start. First, consider triangle. In triangle ABC. This is answer 2. In triangle ABC, which are the midpoints? P and Q are the midpoints of AB and BC, which implies PQ parallel AC and PQ equal to half AC. That will be equation number 1 by midpoint theorem. Start by midpoint. So first equation completed. Now consider the second one. Other triangle. In triangle ADC, which are the midpoints? S and R. S and R are the midpoints of AD and CD. And by midpoint theorem, we get SR parallel AC and SR equal to half AC. Okay. Now question 2 over. Now from 1 and 2 we get PQ parallel SR and PQ equal to SR. Okay. So write that. From 1 and 2 we get PQ parallel SR and PQ equal to SR. Because here PQ parallel AC, SR parallel AC, so PQ parallel SR. PQ equal to half AC, SR equal to half AC, so PQ equal to SR. So PQ parallel SR, PQ equal to SR. Same pair of opposite parallel and equal, then the P figure becomes a parallelogram, which implies PQRS is a parallelogram. Reason? And the reason, a quadrilateral with one pair of sides parallel and equal. Then it's a parallelogram. Write that also. Then it's a parallelogram. Okay. So that's the completed. Now we have PQRS is a parallelogram. So first step over. So here we have to prove PQRS is a rectangle. Now we got PQRS is a parallelogram. So a parallelogram to be a rectangle, we have to prove one of the angles of parallelogram is right angle. So when one of the angles is right angles, all the other three also will be right angles. Okay. Now we have PQRS is a parallelogram. Okay. We proved PQRS is a parallelogram. Now consider we have to prove one of the angles is right angle. So to get that, join BD. First start with the join AC. Now join BD. BD. Then BD perpendicular AC. Let them meet at O. Okay. So this is a right angle. Or right angles. Okay. The perpendicular bisector. So OB equal to OD. OC equal to OA. Okay. Also bisect. Okay. Perpendicular is occurred here. So I wrote this one. BD perpendicular AC. Now consider this one. Okay, here we have this AC parallel PQ. So these pairs are parallel. Also we can prove that BD parallel PS. Can you prove that BD parallel QS in triangle ABD? Which are the midpoints? P and S are the midpoints. P and S are the midpoints of AB and AD. Okay, we consider here this triangle because we need this rectangle. Okay, this figure. We use this figure, that is why I use this. If you use this one, consider this triangle BCD. Okay, so already we have AC parallel PQ. Now we have to prove these two also be parallel. Okay. Now midpoints of AB and AD, which implies PS equal to half BD and PS parallel BD. Okay, or reverse, PS parallel BD and PS equal to half BD by midpoint theorem. Okay. Now we have this PS parallel to BD. So when PS parallel to BD, we can say that these two sides are parallel. Okay. Now consider this figure only. This figure. And name these 2 points also. These 2 meeting points also. Let it be M and N. Now we have a new quadrilateral here. PMON. PMON. This figure. PMON. Okay. In PMON, we have here AC parallel PQ implies this MO parallel PN. Okay. In quadrilateral PMON, MO parallel PN. Reason AC parallel PQ. So when AC parallel PQ, we can say that these two sides are parallel because MO is part of AC and PN is part of PQ. And consider this pair PM parallel NO and PM parallel NO because PS parallel BD. PS parallel BD. PM is part of PS, NO is part of BD. Now consider the MO parallel PN, PM parallel NO, that is opposite sides are parallel. In this quadrilateral, opposite sides are parallel. When opposite sides are parallel, which implies PMON is a parallelogram. PMON is a parallelogram. Now we have this small figure, quadrilateral PMON becomes a parallelogram. Okay. Already we have in this parallelogram, one of the angles is right angles. Now what do we call this parallelogram? Then this parallelogram is a right angle. Okay. Then last step. But in parallelogram PMON, angle MON equal to 90 degree. Reason diagonals are perpendicular bisectors in a rhombus. Okay. So parallelogram with a right angle, which implies PMON is a rectangle. Parallelogram with a right angle is a rectangle, which implies this angle P. Angle P is SPQ. Angle SPQ equal to 90 degree. Okay. Now this angle becomes right angle. This right angle is an angle of PQRS. Already we have PQRS is a parallelogram. Now in this PQRS, one angle is 90 degree, then PQRS becomes a rectangle. Implies PQRS is a rectangle. Reason a parallelogram with a right angle is a rectangle. Okay, this is the reason. QRS is a rectangle. Now question number 2 completed. Now children, next question number 3. ABCD is a rectangle and PQRS are midpoints of sides. ABCD is a rectangle. See the question. Here ABCD is a rectangle. We know that in a rectangle all angles are 90 degree and all sides are equal and parallel opposites. EQRS are the midpoints of AB, BC, CD, AD. So P, Q, R. Yes, midpoints of the sides. Join them to prove so that PQRS is a rhombus. Then these two. Okay, so to be a rhombus, the first one required is all sides equal. So when all sides of a parallelogram or a quadrilateral equal, then it's a rhombus. So we have to prove PQRS is a rhombus. So to get PQ equal to QR equal to SR equal to PS. We know that it's a given figure. The given figure is a rectangle ABCD. So to start with, when midpoints given, at least triangles required here. So we have to get triangle, convert this ABCD into triangle, join diagonal. So start with one diagonal, join AC. Okay. How are the diagonals related in a rectangle? We know that in a rectangle, diagonals bisect each other and they are equal. Okay. In rhombus, they are perpendicular bisectors, but not equal. In rectangle, they are equal and bisect each other. So let's start with the first triangle, triangle ABC. Okay. In triangle ABC, which are the midpoints? P and Q are the midpoints of sides AB and BC. Then by midpoint theorem, we have PQ. This is the midpoint. PQ parallel AC and PQ equal to half AC. Okay, that will be equation number 1. Consider same, the opposite triangle ADC. In triangle ADC, which are midpoints? S and R. S and R are the midpoints of AD and DC. By midpoint theorem, we have SR parallel AC and SR equal to half AC. This is equation number 2 right here by midpoint theorem. Okay, now join. Next to join BD. Next, join BD. Stop this step here. Now join BD. Join BD. So after joining BD, we have two different triangles. This BAD and BCD. So first consider triangle BAD. In triangle BAD, which are the midpoints in BAD, which are the midpoints? P and S are the midpoints of AB and AD. P and S are the midpoints of AB and AD. Implies, by midpoint theorem again, implies all line segment joining midpoints are, that is PS. So PS is equal to PS parallel BD and PS equal to half BD. It will be equation number 3. Now we have PS parallel BD and PS equal to half BD. Now last step in triangle this one BCD, which are the midpoints? Q and R. Q and R are the midpoints of BC and DC. Implies again midpoint theorem. QR parallel BD, QR equal to half BD. QR parallel BD and QR equal to half BD. Equation number 4. Okay, equation number 4. From 1, 2, 3, 4. From 1 and 2 we have PQ and SR are equal. Okay, from 3 and 4 we get PS and QR are equal because both are equal to half BD. So one more to write, last one. In a rectangle, diagonals are equal and bisect each other. Just use equal. Okay, next write that. But AC equal to BD. AC equal to BD. AC equal to BD. Why? Because they are the diagonals of rectangle ABCD. ABCD is a rectangle. Reason, diagonals of a rectangle are equal. Okay, so that is why AC and BD are equal. That is the equation number 5. Now consider all the equations together. Use the equal parts, so no need of parallel parts. Use equal parts only. First one, PQ equal to half AC. Second one, SR equal to half. No need of these two because we have to prove all sides are equal. That is why I use this one. So no need of writing this also. So just if you want to write. Otherwise, no. Okay, no problem. PQ equal to half AC. SR equal to half AC. And PS equal to half BD. Here QR equal to half BD. Okay. So first two equal to half AC. So these are equal. Second two equal to half BD. So those left side are equal. And also we can say that AC and BD are equal. Okay. So when AC and BD are equal, their halves are also equal. Okay. Here PQ equal to half AC. Okay. PQ equal to this half of this one. SR equal to half of this one. And here PS equal to half of BD, this one. QR equal to half of BD. Okay, two of them are half of this one, other two half of this one. That means all are equal. So from 1, 2, 3, 4 and 5, we get all the sides. Consider these sides. Starting one, PQ equal to second, SR equal to third, PS equal to fourth, QR. Okay, PQ side, PS this one, QR this one, SR, sorry, PQ, SR, PS, QR. Okay, all sides completed here. So now in PQRS all sides are equal. That becomes a rhombus, which implies PQRS is a rhombus. Okay, PQRS is a rhombus